Okay, so rules of exponents number 23. You have a power being raised to a power. Power being raised to a power, so that's, you multiply those exponents, all right? So that actually gives you positive 9. If you can kind of think of it this way, and x to the negative 3 means you would have had to put him in the denominator. Then if you had another negative 3, you would have to put him back to the numerator. So that's why he's positive, all right? Now you have this. Now we could put this x in the denominator, all right? Or we could just see that, oh, looks like I have two bases the same, x and 9 plus a negative 1 is actually 8. Now the 2 just gets multiplied to this invisible 1 here. So it's just 2. So you get 2x to the 8th, all right? So it looks like that answer would be E. All right, but over here it's a little bit more complicated, but what we want to do is we want to make sure that we want to cross out what we can here. Now, up at the top, p to the 0 power is just 1, so I'm going to get rid of them. And down below, I see that I have a p squared and a p negative 2. If I added those together, okay, those become 0, so that's gone. So now it looks like I have something a little simpler. I have n squared at the top. I have a 2 times 2. Now nothing is being added down here except exponents. All right, this whole thing is like multiplication. All right, if I would have put a plus right here, none of what we are doing is possible. All right, because then you'd have two terms. This is all one term. Okay, everything in a term can be multiplied and divided. All right, but as soon as you add or subtract something, then it becomes a term. All right. So what's next? We got 4. Now we have an m, a negative 2, an m, a positive 1. If I were to add those, that becomes a negative 1. And then we have an n to the negative 2. Now it's all being raised to the 4th power, but I'm still not going to multiply everything by 4 yet. I'm going to move these two negative exponents to the top. All right. So since the n squared is there and 2 more are coming, then I have n to the 4th. Okay. I still have a 4. He's not going anywhere because this negative 1 applies to the m and the m only, not the 4. So the 4 is going to stay. But now this m at negative 1, he's positive. Okay. So now every exponent is positive. Let's give all of these guys let's multiply it all by 4 times. So we get n to the 16th, m to the 4th, and then 4 to the 4th, which is 16 times 4. That's, did I already do that one? 16 times 4, that's 2. No, 64. 16 times 16. 64 times 4. Carry the 1, 256. Yeah, I already did that one. I'm almost so hard now. Alright, that's your final answer. So that would be, okay, just the order is different. No big deal. And M usually goes first just because it's alphabetical. Alright. Okay, 25. 25 is 5, 3 to the 3a plus 3 equals 5 to the negative a plus 2. Okay, so now this is a really nice problem. You just have to be aware, because you almost want to take a log because you have the variables in the exponent. But because they have similar bases and they completely match up, you can literally just cross off the 5s. All right, because it's kind of irrelevant that they're being raised to a power, because you just want this exponent to match this exponent. Okay, they have to be equal, or else there wouldn't be an equal sign. And now we're just back to basic algebra. Okay, pre-algebra. Okay, and then we're going to move the 3 over to the other side. Get 4a equals negative 1. Going to divide both sides by 4. You get negative 1/4. Okay, so negative 1/4 is there. Now what you want to do though is make sure that when you take negative 1/4, you want to plug them back into here to make sure. No, actually you don't really have to. It's only with logs. You got to be careful. Alright, so negative 1/4 is our answer for C. It looks like 26. You kind of got lucky again. I almost want to change the problem just to kind of show you what probably is going to show up on the test. Because this matches also. What should have actually happened is I wanted you to have 36x minus 2. Okay, that's what I really wanted you to do. Because what happens here then is that these do not match up. So we have to make them match. And so 36 is actually a power of 6. So I can rewrite this with a base of 6, because when they both have a base of 6, I cross them off. But because we have a base of 36 up here, we want to double whatever you have here in order to match what you have here. All right? So then that would be 2 times x minus 2. And then that would be himself. Okay, so we want to double this exponent in order for these guys to equal each other. All right. So now these guys can go, and you're left with 2x. 2 times x minus 2 equals negative 2x minus 1. So 2x minus 4 equals negative 2x minus 1. Let's move this guy over here to get 4x. Move this guy over here to get 4, that'd be 3. Okay, now this is, I'm going to divide by 4, you get 3/4. Now I've changed the answer though. Okay, so you're not going to see 3/4 here, but if I were to do this, 6x minus 2 equal negative 2x minus 1, this guy would come over here to get 3x. This guy would go over there to get positive 1x. So actually the answer for this guy would be 1/3. Okay? Alright, but this is the kind of question that I want you to be able to answer. Alright? Alright, we'll stop there and do the next batch.